So let us solve one more problem on Charpit's method. Problem is solve p square plus q square into y equal to qz equal to qz. Okay, so this is a given problem. So now write the given equation can be written as. So this solution the given equation can be written as. So here p square plus q square into y, bring this term here qz, sorry, minus qz, plus is there, minus qz equal to 0. Okay, so now we take this one as f of x, y, z. So let f is equal to p square plus q square into y minus q. So let us take this one as f. Okay. So now actually what is the auxiliary equation is? Now in this case auxiliary equation is okay, so for this equation auxiliary equation is given by dx divided by minus dou f by dou p is equal to dy divided by minus dou f by dou q is equal to dz divided by minus p dou f by dou q minus q dou f by dou p, which is equal to dp divided by dou f by dou x plus p into dou f by dou z, which is equal to dq divided by dou f by dou y plus q into dou f by dou z is equal to d phi by 0. Okay, so this is the auxiliary equation. So now from this equation we find dou f by dou p, dou f by dou q, then dou f by dou x, dou f by dou z. So differentiate this f partially with respect to p, q, x, z and y, right? So now we differentiate this. Okay, so what we obtain? First we differentiate f. So f is what? P square q square into y minus q. So this is f. This is f. Now differentiating first with respect to p. So dou f by dou p is equal to. So when we are differentiating with respect to p partially, then all other variables are constant. So all q and y all are constant. So here y is constant. So differentiation of p square is 2p, but q is constant, so it is 0. Then minus differentiation of q with respect to p is again 0, which is equal to 2py. 2py. This is dou p by dou f by dou p. Similarly, differentiating with respect to q. With respect to q means treating p and y as constant. So here this is y is constant, take it out. Then here differentiating with respect to q means p, differentiation of p is 0, here 2q, then minus, this is differentiation of q with respect to q is 1, or which is equal to 2qy minus 1, 2qy minus 1. So this is dou f by dou p, dou f by dou p. So dou f by dou q is equal to 2qy minus 1. Next comes dou f by dou x. Differentiating f with respect to x. So it is completely, there is no x term, there is no x term. So there is no x term. So we have dou f by dou x is equal to 0. Dou f by dou x is equal to 0. Right? So this is f q minus qz. Okay. So make this function as, here it is qz, because z is there, so it is qz. Now differentiating with respect to x, in this there is no x term, so differentiation of this whole with respect to x is 0. Next, differentiating with respect to y. Now y term is there, all other functions are constant, so it is p square q square into differentiation of y is, with respect to y is 1, or which is equal to, now this is equal to, q is constant, differentiation of z with respect to y, it is dou z by dou y, or in other words dou f by dou y is equal to, this is p square plus q square minus, this is q, dou z by dou y is again q, dou z by dou x is p, and dou z by dou y is again q, because dou z by dou y is equal to q. So which is equal to p square plus q square minus q square. This plus q square minus q square get cancelled, so it is p square. Next we differentiate partially with respect to z. Dou f by dou z is equal to, so dou f by dou z is equal to, so this is 0, this is 0, then minus q. Differentiation of qz with respect to z is q, or which is equal to minus q, minus q. Okay, so this is all we have determined now. Now substituting all this, call this equation as 1. So this is auxiliary equation, call this equation as 1. Now substituting here, all these in 1, okay. So we obtain, first one is dx divided by dou f by dou p. Dou f by dou p is 2py, dou f by dou p is 2py. So dx divided by minus 2py, then dy divided by dou f by dou q. Okay, dou f by dou q. So dou f by dou q is 2qy minus 1. So minus of 2qy minus 1. Next dz divided by here minus p into dou f by dou q. So dou f by dou q is this one. So minus p into 2qy minus 1. Then minus q into dou f by dou p. So dou f by dou p is 2py into 2py is equal to dp divided by this is dou f by dou x. So dou f by dou x is 0. So dou f by dou x is 0 and dou f by dou z is minus q. So when you substitute this as 0 and here it is minus q, it becomes minus pq divided by minus pq. Then this is equal to dq divided by this is dou f by dou y. So dou f by dou y is equal to p square. Correct? This is a dou f by dou y is equal to p square and dou f by dou z is minus q. So when you substitute these two values in this, okay, so dou f by dou y is p square, so this is p square, then minus this is dou f by dou z is q, so minus q square, so it is p square minus q square, okay. So this is dq divided by dou f by dou y plus q into dou f by dou z. Okay, so now take any two equations. That is dp divided by minus pq. Take these two equations. dp divided by minus pq is equal to dq divided by p square minus q square. Okay, so in this case these two equations can be solved. Okay, so solve these equations taking any, it is common. Okay, on solving this type of equation we'll get p dp plus q dq is equal to 0. Solve this equation using variable separable method or substitution method. Okay, and solving this, we get this equation. Then integrating, this is p square by 2 plus q square by 2 is equal to c square, or p square plus q square is equal to 2c square, taking LCM and all that. Then now substituting this value in 1, substituting this in given problem, that is p square plus q square into y is equal to qz. So in this equation substitute this value here, which gives 2c square into y is equal to qz. 2c square into y is equal to qz. From this equation q is equal to 2c square y divided by z you will get. Okay, so now substituting this in equation 2. So that is, now substitute again this value here. For this is equation 2. Now substituting this q in equation 2, that is here. In this equation we substitute, so p square plus q square, that is 4c raised to 4y square by z square is equal to c square. So bring this term here, you will get p square So substituting this value q in this equation, we will get p square plus this square 4c raised to 4 y square by z square equal to c square. So from this equation we calculate p square, c square minus 4c raised to 4 y square by z square, or p is equal to now taking in LCM all that, we get c z square square root of z square minus c square y square whole divided by z we will get. So now we obtain this p and q. We obtain both p and q. So now substituting p and q in the equation, dz is equal to p dx plus q dy. In this equation we have to substitute that. So then we get dz is equal to p dx. P means c into square root of z square minus c square y square by z p dx plus q dy. Q means 2c square y divided by z p dx plus q dy. So this we obtain. Okay, so now integrating. Okay, so now we integrating. So or otherwise we can take here common term, so which gives multiply of taking z common. So in this case 1 by z common and 1 by z common, taking 1 by z common and cross multiply here, which implies z dz is equal to c into square root of z square minus c square y square plus, now this 2 is constant, then c square is constant, right? So let us take the product of two constant is again a constant. So let us take this 2 into c square as c1 square y by z dy. So you can write here 2c square is equal to c1 square. Okay, 2c square, we can take 2c square is equal to c1 square. So then we will get this equation, and here z will not come because we have taken z common. So that means z dz and bring this here minus c1 square y dy is equal to c square root of z square minus c square y square. That is, now this can be written as, now this is nothing but, this term is nothing but what? Differentiation of z square minus c square y. Means when you differentiate this, you will get this one, because now see here, this when you differentiate this, what you obtain? 2z minus c square into 2y dy. So z minus y dy, c square y dy is there. So therefore this is nothing but, only the thing what 2 is not multiplied, so that we can adjust that. So therefore this is nothing but 1 by 2 into differential of z square minus c1 square y square, which is equal to or divided by, bring this term here, square root of c square y square is equal to c. Next is integrating. Since numerator is the differential of the denominator, so therefore integrating we obtain so integrating we get this integration is z square minus c square y square raised to 3 by 2 divided by 3 by 2 into 1 by 2, this 1 by 2 is equal to c, or this 2 to get cancelled, z square minus c square y square raised to 3 by 2 divided by 3 is equal to c. is equal to c. Okay. Or z square minus c square y square raised to 3 by 2 is equal to raised to 3 by 2 is equal to and here this comes in the numerator, sorry, mistake. So this is z square minus c square y square raised to 1 by 2. When it comes in the numerator, it is minus 1 by 2. So n plus 1. So minus 1 by 2 plus 1. Oh, this is what should be 1 by 2, and it's also 1 by 2, and it is 1 now. Okay, this is 1 by 2. Make it as 1 by 2. So this is also 1 by 2 is equal to c. Now squaring on both the sides, which gives z square minus c square y square is equal to c square. Okay, or z square is equal to c square plus c square y square. Z square is equal to z square plus c square y square. Okay, so and one more term here, making variable while making variable separable method. So this is differential with respect to x. Okay, so this is a differential with respect to x. Dx is there. Here we have forgot to write this dx and dx, and here also we multiply with this dx. So when we integrating both sides, so this is integrated and we have written here, but this is not integrated, so therefore this c integration of dx is x, or here also x, then c square, this is on squaring on both the sides, c square x square. Okay, c square x square, on squaring on the both sides, this will come c square plus c square x square plus c square y square. Okay, so this is the solution of given differential equation. Okay, so this is the solution. Just write here. Okay, z square minus c square is equal to cx, then plus integration constant, one more term, plus a, then here integration constant plus a whole square. You have to integrate squaring on both the sides, cx plus a whole square, or z square is equal to cx plus a whole square plus c square y square. So this is the complete solution of the given differential equation. So with this I conclude this class and continue in the next class. Thank you.